First off, I'm Nigel Umbayak, one of the customer success managers here at KETIV Technologies, your host for today's Autodesk Virtual Academy and just about every other Autodesk Virtual Academy we've done. So today I'm joined by one of my colleagues here, Jeremy. Jeremy, how's it going?
Oh, it's going pretty good. How about yourself?
I'm doing well. I'm doing well. Jeremy's one of the application engineers here on our team and works primarily on our Lifeline support team. So odds are, if you've called into Lifeline support in the past, you might have gotten Jeremy or one of his other, group members to help you with your problem. So without further ado, let's hop into today's session. Today we're going to be going over the Inventor Design Accelerator, which helps you accelerate your designs. Wow, very intuitive there. But it is a part of Inventor, a section of Inventor that's often not used for the most part. And we see that a lot of people can gain a lot of time as well as alleviate a lot of headache during the design process for mechanical design specifically by utilizing some of the design accelerators. The most commonly used ones are things like bolted connections or frame generator, but today we're going to be going into V-Belt specifically. I know that Jeremy has a lot of industry experience with that, so he's the best person on our team to be able to show you that. If anyone has any questions at any time, go ahead and type those into the panels. Without further ado, let's go ahead and pass it over to Jeremy. Jeremy, you want to take it away?
Yeah, thank you. All right, so today we're going to go over the Inventor Design Accelerator with an emphasis on V-belts and pulleys. A little bit about me. As Nigel said, I'm an application engineer with KETIV. I've been doing design and manufacturing engineering for 12 years. Been using Inventor for around the same. I came from industrial pressure washers with a emphasis on designing power transmissions for 8. So what is Design Accelerator for V-belts? What's Design Accelerator? It's used to simplify the process of design. It automates geometry and part creation. There's multiple different design accelerators built into Inventor. We're going to be primarily looking at the V-belts. We're going to be using it in 2 different samples, one for drive creation and validation and make sure everything fits right and is good with the ANSI and ISO standards set forth for V-belt drives. And the other one is going to be using the drives in your own system that you may stock at your warehouse and the calculations that your company may have as a standard for belt drive systems. So the first one we're going to look at is going to be the sample that has components that are already used in your warehouse. And this way you're not having to bring in new components, new pulleys, new pumps, new belts. And if you already have, company standard calculations that you would use for said drives. So let's take a look at the sample.
And all of this stuff for the design accelerators is done in the context of an assembly. You'll see the design tab within the assembly environment itself.
So as Nigel was saying, yeah, all design accelerators are done in assemblies, and next to the assembly tab, you'll have your design tab. And some of the accelerators, you have bolted connections, clevis pins, you have frame generator here, a frame analyst. You can do shafts, gearing, bearings, belts, keys, cams, splines, O-rings, and springs. But for this instance, we're just dealing with V-belts. There are synchronous belts and roller chains in here too. So since I already have my layout, I have a 10 horsepower electric motor, 1750 RPMs, and I have a high pressure pump here. And I've used my calculations to figure out what pulleys I have in stock, or I stock as a standard, to figure out what the calculations and ratios for horsepower transfer are going to be. So what I'll do is come up to the V-belts. And at the top of the component generator, you see the belts, and you can select between classic and narrow belts. They have all the ANSI and ISO standard belts here. But in classic, we're going to go with BX. So the first thing you'll do after you select the belt is you need to select the belt mid-plane. So it throws two, representations onto the screen. And since I already know that my horsepower transfer is going to require 2 belts, in this line here, you enter the amount of belts. And then you come down to your pulleys. Your first pulley in the system is always your driver. It's the powered pulley. So in this pull down here, and since I already have existing components here, I select existing. And then I'm able to select the pulley. And then for the second one, same thing, come down to existing, select existing. And then you can see how the lines are red here because it's going to give me a couple of errors because in the system, this is not considered a free sliding pulley. So we'll hit OK, some errors pop up. But it lets me get the representation for what I need for the items I have in the warehouse.
Yep. And then from I know that you mentioned it's like not a free sliding pulley, Jeremy. Can you explain a little bit deeper what that means?
Yes. In Inventor, it's going to calculate what the tensions of the belts need to be and what the starting position of the belts are to find the proper belt length for your application. And since this pulley is fixed onto the pump and the pump's fixed at a certain distance, it's not recognizing that that is an adjustable pulley. So it's not wanting to get all the data for its calculations correct. But the one caveat to that is if you do edit the design accelerator, you can come up here and it'll tell you the approximate closest belt size it has, or it'll recommend for where the pulleys are. It's not the best method, and that's why we'll go on to the sample too, but this is one to use if you already have the components in stock, or you may have already built the machine and done your calculations and your testing and said, okay, this works. I know these distances are fine. But if you haven't done any of that, there's another sample we're going to go over. Close this out. All right, so now we're going to use the pulleys and calculations that are built into Inventor. And why would you use this? The components and all the calculations are all based off ANSI and ISO standards and pulley and belt manufacturers' recommendations. They send them in, they send Autodesk all their specs for their pulleys and belts so that in the Inventor system, it's all correct to real world. So let's open up our second sample. All right, as you can see in this sample, I don't have any pulleys yet, but same components. So we'll go through the same process of design, find the V-belts. And
and I guess, Jeremy, too, just to stop you before you keep moving here, right? This is like kind of one of those situations where you have a design problem, right? You need your motor and you need your pump, but you don't know which pulleys, right, perhaps that you need to purchase or procurement to get, as opposed to the last example, right, where it was kind of like, let's use what our procurement has maybe on the shop floor already to be able to utilize and add to the assembly. But in this case too, Jeremy, if I remember correctly, the motor is still fixed, but the pump isn't. Can you show that a little bit before we jump straight in?
Yeah, I'll show that right now. Yeah, my motor's going to have a stationary position. I'm going to use a pump adjustment. You can use a motor adjustment and have the pump is stationary, but my background, I've always, adjusted the lightest component, found that usually the easiest. But you can see that the pump's constrained in a line with the shafts, but the distance from shaft to shaft is adjustable. And that's what the sliding pulley is going to require.
Yep, and that takes care of like the tensioning question that
Yes.
caused the error before, where, hey, it's going to use that approximate size belt for that distance. Well, in this case, you'll be able to get it perfect because it'll just throw that pulley into a location where you get the correct tension on the belt.
Yeah. So going back to V-belt, and after you complete one of these generators, it'll leave the same information that you used the last time. So if you're going to be using a different type of belt, or you just want to completely erase the information that's in there, there's a little reset the calculations up here. So we'll do that just so we can start with the clean slate. So going back through, we're going to choose the belts. I'm going to choose a BX again. I'm going to choose the mid plane. And when you choose the mid plane on this, since I'm not going to use a component, I'll show you how that's going to go. So down here, we're actually going to create components. And I know this is still going to take 2 belts for the transfer. And then,
and so that's just a selection, right? Where
yes,
you have the selection to create the geometry itself or to reuse existing geometry.
Yes. And the geometry that it creates are all standard dimensions of manufacturers' pulleys. So then next to the pulleys, you have the placement. And since I know where my motor shaft is, I'm going to click on the fixed position by selected geometry. And I'm going to click on the shaft. Place it right there. And up here, you'll see this mid-plane offset. That's to tell it how far either on the shaft or off the shaft you want it. And for this representation, just to put it onto the shaft. And then the 3 little dots next to it are your pulley properties. Now you can get into this and make custom sized pulleys for your application, but if you're using off the shelf, the diameter, click here. These are what Inventor has loaded as standard off the shelf pulley diameters. And since I already know what the diameter I'm going to use is 4.9, hit OK. And then for the next one, we're going to put it on the sliding position. And we're going to use this plane that's centered on this shaft here. And this way it'll only slide in accordance to that plane. So you can grab the little arrow here and bring it over, and it'll let you. And then same thing, we're going to come over here to the pulley size. And you can design this in 2 ways, one by the diameter or by the transmission ratio. So since the transmission ratio is going to be 1.48 for the RPM conversion, hit OK.
Yep, and that's just tabulated values that you had based on
the
RPM of the motor versus the RPM that you need on the
pump to get the particular pressure and flow I'll need. I have these calculations already.
Yep, and like just from industry experience, Jeremy, that's something that your company just happened to have, or you were calculating when you were trying to solve some of these design problems?
Yeah, well, I've done it both ways on that. I've calculated some of them in here, but most companies will have a standard because they'll have different horsepower per belt ratios that they'll use, or service factors for whatever their particular standard for their industry is. So let's make this a little easier to see. And so now you can see that the lines are green. It means that it's able to tell you what size the belts are going to be needed. And you can see that up here in the datum length of the belt. And then if you also look up here, it now says a BX46. So if I was to place my pulley in this location, let it be good, I know that I'm going to need a BX46 belt for this application. Or I can bring it, out here, go to a 51. And these are all information that's in Inventor for the belt number and for the datum length of the belts. So we'll
it's sorry, real quick, Jeremy, too. So it's only sliding. This is a question that came in. So it's only sliding, like free sliding, based on like a length of belt you can use.
Yes. It's gonna lock it into the belts lengths. Yeah, it's only gonna slide it from a BX38 to a BX42, whatever the belts are in the system. And you can add your own belts into the system with the datum lengths from the manufacturers. You can add that into the XML files for this. So if you have particular belts that aren't in the system, you're able to add those too. So we'll say that this is going to work. And then what I'll do is pull my pump out here so I can see it a little bit better. I'll constrain the shaft to just the center of the pulley. Okay. Now I can see, well, my mounting holes are going to be really interesting to the frame here. So maybe I need a smaller belt. So if I right click, I can edit the belt, and I can just go to the next size down in the system. Hit OK again. And now I'm able to go, okay, now I know I'll be able to put holes here without interfering with the frame itself, being able to go through that.
So it's one of those things where you had the system, right? One of those problems where you have the system and then you have the pulleys determine the belt length to determine the position of like the second component, the driven component, as opposed to starting the other way around.
Yes. And in these samples, we're only using a 2-pulley system. In V-belts, you can use multiple pulleys. You can set it up to have an idler pulley or another driven pulley off the other side. But for this instance, we're only using the 2. But the nice thing with this is when you're designing something, if you know the overall dimensions of what your frame is, like I have here, and I just happen to throw these mounting holes just on what I would have thought was going to be the distance. But now I know to use a standard belt properly, that's going to be slid back a little bit. So if you're having a hard time figuring out where you're going to place the component, this helps you figure out what distances you'll need. And now I can go, okay, if I'm back here, maybe I can shorten up the frame a little bit, save a little bit of material, save a little bit of cost. All right. So that's going to be the second sample. And all these rules, just to reiterate, are all based on the standards that ANSI and ISO have for these when you're using the components out of Inventor, which is always a nice thing. So a little bit of a summary of what we've gone through and gone over. The design accelerator, where it is. You always have to be in an assembly to start any of them. And it's going to want you to have the file saved before it starts it. We went briefly over just some of the different accelerators and then went over the V-belt drives accelerators. And remember, you can use the parts and your own company standard calculations to set it up, or you can use all the rules and calculations that are built into Inventor. So it can save you time and make sure that you have a good calculation for what the standards are.
Yeah, so with that, we can jump into some questions. I know we got a couple during the actual demonstration itself. So if anyone has any more, go ahead and type those in, and I'll go ahead and take those. But the first question that came up a couple of times too would be, how do we add like our custom pulleys or our like belts to the system? And that was two separate questions. I guess it makes sense. Same concept.
Yeah, it's in the design data XML file for Inventor. To get you a step-by-step, that's something that I'll have to take offline and get something concrete written down for that. That's something that's...
Yeah, so it's like, it's the same concept as editing a bunch of design data information from Inventor, right? It's all XML files and stuff. So
yeah. And you just, it's information that you'd get from the, you know, the pulley or the belt manufacturer.
Yep, yeah. So if you already have that kind of information, right, like just like tabulated, or you know what you have in stock from your vendors, you can add all of that to Inventor. I know that we didn't go too deeply into the pulley design window, but there's a lot of parameters in there that could be edited to make custom pulleys too, if what you use isn't in there.
Yes.
All right. Another question came through is like, is there a way to automate this stuff in iLogic? So that's a little difficult. When you're talking about some of the design accelerators and automation, I know the automation is really hot topic right now. It's kind of hit or miss for some of the design accelerators, specifically for things like frame generator just doesn't work at all. So definitely let us know what your application is, and then we can figure out whether or not iLogic or using VBA is going to be the fastest way to automate that design process. So. All right, we'll ask a question. It seems to generate a pulley or a gear, but not generate a part for the chain. Would you have to draw your own chain? I guess belt. Maybe he means belt. So when it adds the belt in the system, does it add it as a component to the assembly?
Yeah, it does, and it'll also save it as an assembly folder.
Sub-assembly, right?
Yeah.
Did you want to just open that in Inventor real quick and just show what
Yeah.
that looks like in the model tree?
Yeah, as you can see the belts are here.
Yep, and because there's two, it put them in a component pattern because it's the same component and you get double of that length. Cool. Let's see what else we got for questions. There's a couple more that coming, and I have multiple sources to take a look at, so it's a little difficult. Let's see what we got. All right, in terms of like some of the other design accelerators, when are we going to go over things like spur gears or shaft design? So we don't have enough time to go over all of the design accelerators today. So if there's a specific one that you or your team want to see us go through an example of, let us know. Also, Inventor has a bunch of awesome tutorials. So Jeremy, if you want to go to the Get Started tab on Inventor real quick. It's like next to environments, I think.
Yeah.
Yep. So there's a bunch of samples already, and then there's a full-blown tutorial gallery. If you want to just click that real quick for me, Jeremy. And there's a lot of public tutorials that Autodesk or other users have generated. So if you search, so for example, just like search frame generator, I guess, or just frame. Maybe not. All available, not installed. So place, change that to all available. Perfect. So you've got things like frame analysis, frame generator, all of those are available as public from like whether it's Autodesk or other people in the community. So if you want to start learning some of this stuff and you want to do some examples yourself, these tutorials are in the application itself. And I know the team that worked on the tutorial section of Inventor, and they released this a number of versions ago. Really proud of this, and they put a lot of time and effort into it. So it's a really good resource to use if you haven't already looked at it. All right, and then in terms of recording, when is this going to be up? So I'm recording this right now. So hello, future self. I guess we will have this up on our YouTube channel sometime in the next week, I would imagine. Yeah, probably in the next week or so. And then let's see, is there a limit to the amount of belts you could have in one assembly?
I'm not 100% positive on if there's actually a limit. I've never really tried that.
I don't imagine there's probably.
Yeah. I'd have to look into that particular one.
But you could have like, I guess an extension to that question that I personally have would be in terms of like, if you had like a 4 pulley system or something like that, where you have like one driven pulley and then like, say for example, 3 or one driving pulley and then 3 driven pulleys. Is that possible?
Yeah. Yes. You're able to add multiple driven pulleys. What the max is, I'm not 100% positive. I haven't looked.
I don't imagine you'd have like 4 belts off of one driven pulley, going to a bunch of different stuff. For most.
Yeah, as I'll say, I've done 4 off of it for 3 to a pump for power and then 1 to a generator, but over 4 I haven't done.
For sure. And then there's another question is this available in older versions of Inventor? So it depends on how old your version of Inventor is, right? So if I can't remember a version that doesn't have this design accelerator stuff in it. I know it's a lot of versions. So if you have Inventor, just go ahead and take a look at your design tab and they should all be there. I think the most commonly used ones that I've seen are like frame generator and bolted connections. So I know those have been there for a number of versions. I don't imagine anyone who maybe doesn't have that I know of. Maybe I know some like 2010 customers and maybe they don't have it, but if you were in a version of Inventor in the last 5 years, you have all of this.
Yeah.
All right, and I'm going to check YouTube real quick, make sure there's no questions there. It looks like there's some emails that were sent to us. Okay, so cool. I'll go ahead and address those via email that came through that direction. All right, I don't think we have anything else to add. It looks like we went through all of the questions. Short and sweet AVA went through a lot of the V-belts and the options for that. So Jeremy, do you have anything else to add before I let everybody go?
No, I think I'm pretty good.
Cool, awesome. Jeremy, again, thanks for joining us this morning and putting this together for us. I know that your industry experience here made it so it made sense for you to be able to be the one to do all of this for us for this particular topic. Can't wait to see what we have coming up next, maybe we'll go over one of the other design accelerators like shaft design, which a lot of people have asked me about as well. So for next week, we're going to be going over what's new in Moldflow 2021. So for those of you who are into mold design, perhaps for injection molding, that might be a webinar for you to join. So Jeremy, again, thank you for joining us, and the audience as well. Thank you for joining us.
Well, thank you.
Absolutely. We'll see you all next week, same place, same time. Have a good weekend, everybody, and stay safe. Bye-bye.
All right.